This is Math 3, Final Review Unit 4. And a reminder that for this unit we're doing homework notes, so I'm just picking problems off of this review packet. I've already done unit number 1. I'm now doing number 7. Gentlemen, I need you guys listening. The question I've asked is, right now the way it's written, can I cross reduce? Thumbs up or thumbs down? Okay, and why am I not allowed to reduce? Because there's what? Plus and minus. What do I have to do first before I can cross reduce? Or any kind of reduce. What is it? Factor. Factor first. Factor first. Okay, on the top left, the 3x plus 2, there is nothing to factor. So that's going to stay a 3x plus 2. On the bottom left, I can do a GCF factor. So I'm going to ask you guys to do that now with your shoulder partner. Take out a GCF of x. All right. Michael, can you tell me what you have left in here once you GCF out the x? 5 what?
See, I can't even see, so I paste up to see.
You can't see, like, because of the angle, or because?
No, I can't see because I can't see.
I'm going to have you sit right here and just scooch up right there. You would be at a better angle and you can scooch up. Oh, and that's actually probably a better angle for you anyway. Yeah. Go. Okay.
What did you want?
Not calling me?
Maya, can you tell me what you got?
Yeah, Maya.
Wait.
Right here, after you GCF.
Oh, 5x minus 1.
Thank you. And then here with your shoulder partner, if you haven't done it already, I'm going to have you guys double bubble, guess and check, trinomial, guess and check, and here as well, trinomial, guess and check. I will, with the 10, the only possibilities for 10 are 10 and 1 or 5 and 2. And for 6, 6 and 1 or 3 and 2. With x's, of course. You can scooch up if you need to. I said, if you need to. And remember, when the last signs are negative, that means one is positive, one is negative. All right, a volunteer for the top one? Nobody's got it? No one? No one has this one here for 10x squared plus 3x minus 1? Yes.
5x minus 1. 2x plus 1.
And 2x plus 1. Anybody else agree? I see a few nods. Yes, that works. That's 10x squared, that's negative 1. Inside is negative 2x, outside is positive 10x. That does give us a 3x in the middle. Okay, bottom one, go ahead and do it. I'll give you guys a hint. It is 3x and 2x. And then you have to figure out where to put the 2 and the 1 or the 1 and the 2. Which one's positive, which one's negative. All right, do we have it? Savannah, do you have it? You're thinking? All right, anybody willing to share? 3x plus or minus? Anyone have it? No? Plus what?
Plus 2.
Thank you. Plus 2 and 2x minus 1. All right, and now we are ready to reduce. I'm putting parentheses around that binomial. And do you guys agree the 3x plus 2 can reduce? The 5x minus 1. Now, what about the 2x plus 1 and the 2x minus 1? Are they opposites? No, they are not. They are nothing. They have no special name. They do not reduce. They are nothing. They stay there. Parts of it do not reduce because I cannot reduce bits and parts. Remember, we called them families. They stick together. We do not reduce bits and parts of them. So it's 2x plus 1 in parentheses. And the parentheses are no longer necessary at the top. You can put them. You do not have to. 2x minus 1, those parentheses are necessary because there's an x there in the denominator right there. Don't forget them. And that there is your answer. Okay, the next one I am doing is number 12. So go on your worksheet to number 12. Look to see what it's asking you to do. It's asking you to multiply, divide, or add two fractions. What is it asking you guys to do? Add two fractions?
Yeah.
X over x minus 2 plus 7 over x minus 3. Okay. A lot of kids struggled with this unit on when do I multiply by the same thing and when do I multiply by what's missing, right? A lot of people struggled with that. When there's an equal sign is when you multiply by the same thing. Is there an equal sign here? No, so I do not multiply everything by the same thing. Now, I will tell you this, whether there's an equal sign or not, you're always going to find a common denominator when you're working with fractions. And you're clearing or you're adding fractions, you are going to find a common denominator. But sometimes you multiply only by what's missing, and sometimes you multiply everything by the same thing. So when do you do what? When there's an equal sign is when you multiply everything by the same thing. Is there an equal sign? No. Okay. So we're still going to find a common denominator, but we're not going to multiply everything by the same thing. Okay, now, because there's a binomial, I'm going to remember to put parentheses here and here. And I'm going to remember that they have nothing in common. There's no x's in common because it's a big chunky piece. And I'm going to make my big fraction. And since they have nothing in common, what is my common denominator? They have nothing in common, so I take one of each. What is my common denominator? Good job. X minus 2, x minus 3. So I'm going to ask that question again. Am I going to multiply everything by the same thing? No. We only do that when there's a what sign? Equal sign. Or a complex fraction, which there is not. Does anybody remember what a complex fraction is? A fraction within a fraction. Okay, so when you're just adding or subtracting fractions, this is where you multiply only by what's missing. I'm going to repeat that. This is where you multiply by what's missing. So on this first fraction, I want it to look like this, but I only have this. What am I going to multiply by? What's missing? So I do top and bottom by x minus 3. And distribute, oh, well, I'm not going to distribute yet. I'll write it down. X times x minus 3. Next one, I have the x minus 3, but I want it to look like this. So what do I multiply top and bottom by? What's missing? What's missing? X minus 2. So then I have plus, because that's what's in the middle, 7 times x minus 2. All right. Now I am ready to distribute the x here, distribute the 7 there, and combine like terms. X squared minus 3x plus 7x minus 49. And the denominator is going to stay as it is. Now I want you to go ahead and combine like terms in the numerator. Where? Tell me again. Oh, right here, right there, and right here. Thank you and thank you. That's me not reading my handwriting properly. So thank you guys. And this should be a what? 14. Thank you, thank you. All right, what do we end up with? X squared plus what? 4x minus 14, not 49. And then x minus 2, x minus 3. And before we go on, what should we try to do to the numerator? Factor. Think about it with your shoulder partner. Can you factor that? Think of the factors of 14, 1 and 14, 2 and 7. That could add up to 4. It may not factor, but you at least try. I hear a few of you saying it. Does it factor? No. You're right, it doesn't. This then is your final answer. Okay, questions on 12 before we move on. Okay, next one is 15. Which is 4 over x minus 3 minus 3x minus 5 over x squared minus 9. And what are they asking us on 15? They're still asking us to add or subtract. So this one is a subtraction problem. Okay, so like number 12, I'm still going to find a common denominator. But what do I have to do here first to the x squared minus 9? I have to break it down. I have to factor it. Do you guys agree? Yes or no? Okay, so I'm going to rewrite it. 4 over x minus 3 minus 3x minus 5 over x plus 3, x minus 3. Why is that? What's that method called again? Good job. Difference of two squares, dots. Okay, now I'm going to find a common denominator. Let's do that first. What's my common denominator? First, what do they have in common? Oh, let's put parentheses, and I'll ask again. What do they have in common? It's families, chunky pieces. X minus 3. What's left over? So what's the common denominator? X minus 3, x plus 3. What's the common question I get every time? Shouldn't it be x minus 3 squared because there's 2 of them? No, because how many does each one have? Only 1. So x minus 3, x plus 3 is a common denominator. But do I multiply each side by what's missing, 1 finger up, or do I multiply each side by the same thing, 2 fingers up? What's missing, or everything by the same thing, 2 fingers up? How do I know it's only by what's missing, 1 finger up? There's no equal sign. Okay, so let's go ahead and rewrite it. Common denominator. And first fraction, I have an x minus 3, but this is what I want. What am I going to multiply top and bottom by? X plus 3. And then the denominators would be the same. So then I have 4 parentheses x plus 3. Next one, Is anything missing on the next one? No. So do I need to multiply by anything? No. If you wanted to show it, you don't have to, but if you wanted to, what would you multiply top and bottom by?
1.
Is it necessary? No, you don't have to. I'm just showing you that if you wanted to, it's a 1. Now, I messed up, and a lot of kids make this mistake. I did address it when I taught this unit. Does anybody know where I messed up? And a lot of kids make this mistake. And it looks like maybe a lot of kids would again because nobody's catching it. And that's okay. That's why I'm talking about it now. Okay, I'm gonna address it now. Are you guys ready? Everybody's listening? Are you thinking you know what it is? Is that no? Distribute the negative. Good. Remember this. When there's a subtraction sign between fractions, do you have to remember to distribute that negative? Yes, there's not going to be a hint, hey, distribute the negative. You have to remember to think of parentheses here. They're not going to write them there. You have to remember to think of them there and distribute that negative. There's not going to be any kind of reminder, any kind of hint. You just have to remember if there's a minus sign between fractions, that minus sign goes to the second fraction through all of the terms. So 4x plus 12 minus 3x plus 5, not minus 5. Go ahead and combine your like terms. All right, what do we get? All this is over x minus 3, x plus 3. So we get x plus what? Plus 17 over x minus 3x plus 3. Any questions? We're good? Is that a yes? All right, next one I'm going to do is number 18. And take a look at 18 on your paper. What is it asking you to do? Is it adding, subtracting, or solving? Solving and check for what? Extraneous solutions. What does that mean again? When you do all your work correctly, but your solution what? Your solution what? Doesn't work? Okay. All right, let's write it down. Where is it at? 2 over x minus 1 plus 2 over x plus 2 equals 6 over x squared plus x minus 2. All right. Now, when we do this, same as the last two we did, what am I going to do here first? Factor. So let's do that first. 2 over x minus 1 is going to stay. 2 over x plus 2 is going to stay. Equals 6 over, with your shoulder partner, double bubble. You have it already? Tell me what it was.
X plus 2, x minus 1.
Do you guys agree with him? Does anybody look at these two sometimes for guidance? I usually do. Like, usually they're going to factor to whatever these two are. Okay, don't forget, especially if they're giving you a reminder with extraneous solutions, look for your restrictions. What are the two things that X cannot equal? Talk about it with your shoulder partner. What two things can X not equal? All right. Anybody have it? Two restrictions are -2 and +1. -2 for that one, +1 for that one. And it's the same thing here. Okay, now I am going to find a common denominator. And because they're big chunky pieces, my common denominator is two chunky pieces. What are they? What is it? What's my common denominator? Nobody knows? Oh, nobody knows? Do you guys agree with her? X plus 2, X minus 1. All right. What am I going to do? One finger up, multiply by what's missing, or two fingers up, multiply everything by the same thing? Why is it multiply everything by the same thing? There's an equal sign. Do you guys agree? So I'm going to multiply the right side and the left side by X minus 1, X plus 2. Okay, and then we're going to reduce. On the very first one, what's the only thing that reduces? Okay, that's still a good chunk, because then I'm left with 2x plus 2. I'll reduce on the next step. Here, the x plus 2 reduces. I'm left with 2x minus 1. Again, I'll reduce on the next piece. Here, very nice. Everything reduces, and I'm left with 6. I'm going to let you guys distribute. I don't know if I used the word reduce earlier. I meant distribute. Distribute, combine like terms, and solve. Go ahead and do that now. Okay, did you guys get 2x plus 4 plus 2x minus 2 equals 6? Combined, what does that give you? 4x plus what? And you guys subtract? 4x equals what? 4x equals 4. Divide. X equals 1. Final answer? All right, how many of you stopped at x equals 1? And it's okay if you did. It's okay if you did. Be careful. Do you think they'd have that answer in a multiple choice test? Most likely letter A, 1. And you're super excited because you did all this beautiful work and you're like, yes, I got 1 and 1 is there. I know I got it right, and it's wrong. Why is x equal 1 not your answer? It's extraneous. X cannot equal 1. What's the true answer? No solution. Be careful. Got it?
Are we gonna have enough space on our test, or are we gonna have to do it on a separate piece of paper?
You'll have room on the test. And if not, I'll give you scratch paper. All right, we're good? Well, you know what? I lied. I think I need to give you scratch paper because I want to say they copied it on itty bitty paper, which also annoyed me. Are you, yes.
Can you do 17?
The next one, the next one I have is number 21. What is number 17? Is it because of the 3 or just because?
Just because.
Let me do the next one first, and then when I'm done, I'll set it up for you guys when you're working on it. Okay, I'm gonna do, which one did I say? 20, 21. All right, 21 and 22, do all of the following. A through K for f of x equals 1 over x plus 2 and then plus 3. Okay, A, sketch the graph. All right, we're ready? Do you guys remember how to do this? To draw our asymptotes, do I go right 2 or left 2? Left 2?
2 up 3.
Left 2, up 3. Good job. Everybody agree with him? And then because it's positive at the numerator here, positive 1, I do top right, bottom left. One of you guys, there was one of you students who told me, Alex, was it you who thought of it, who said you think of it because it's positive, it goes like positive slope this way? Was that you that pointed that out to me? One of you said it to me, and I don't know who it was, but it was like an awesome way to think of it, who said, I think of it because if it's positive at the top, I think of it as positive slope, and positive slope goes this way. So it's those two, and negative slope goes this way, so it's those two. Anybody gonna claim who that was? Whoever it was, I was like, oh, that's pretty cool. Okay, no? All right, so it's top right, bottom left. So it's gonna look something like that. And like that. Malia, could it have been you? Was it you that said that? No? All right. Okay, so there's a graph. This is part A. Part B. Find the y-intercept. Is that what part B is? Find the y-intercept. How do we find the y-intercept? We set what? X equal to 0. So I have y equals 1 over 0 plus 2 plus 3. What's 0 plus 2? So I have 1/2 plus 3. You can find a common denominator. It's easier if you don't. What's 1/2 plus 3? Or 0.5 plus 3? 3.5. 3.5 or 3.5, however you want to write it. And look where I went through. I mean, my graph is approximate, but I went through about a little bit higher than 3.5, but it was pretty darn close. And I write really big when I do mine on my own paper. You don't have to write yours this big. Question C, find the x-intercept. How do you find the x-intercept? Set y equal to 0. 0 is f of x, so 0 equals 1 over x plus 2 plus 3. Before I multiply both sides by x plus 2, what do I subtract over first? I subtract over the 3. What's 0 minus 3? Negative 3 equals 1 over x plus 2. Now I multiply both sides by what? Distribute. What does that become? Negative 3x minus 6. Go ahead and solve that. Add 6, divide by negative 3. You do end up with a fraction. Add 6, divide by negative 3. Hello, Mrs. Torres. Yes. Uh-huh. Okay. Uh-huh. Bye-bye. Okay. What do we get? Negative 3x equals 7. So your x-intercept is what? Negative 7 over 3? Yes? Okay, and what does part D ask for? Part D is asking for the domain. Domain is from left to right. Negative infinity to the dotted line to infinity. Negative infinity to the, what's that asymptote? Negative 2 parentheses union negative 2 to infinity. And what is letter E asking for? Same thing, but from the bottom, negative infinity to that asymptote, and then that asymptote up to infinity. Go ahead and do that now. All right, what did we get? Negative infinity to what? 3. And then 3 to F. State the equation of any vertical. Which way is vertical? Up and down or right and left? Up and down, and which one's that? X equals or Y equals? X equals, because X men stand tall. And what is that? X equals what? Negative 2. And G, is that one asking for horizontal? State equations for horizontal asymptotes. Horizontal is this way, and that one's Y. Are you sleeping? So what is that? Y equals positive what? Letter H is what? Where is it what? Okay, so you're walking along the hill, increasing or decreasing? Going downhill. What about here? Going up or down? Okay, is it ever increasing? Okay. I state the interval in which the graph is decreasing. Okay, is it decreasing here? Yes or no? So negative infinity to what? To the dotted line, which is negative. And then union, negative 2 to infinity. State the interval where it is greater than 0. This is the one where kids struggled. Greater than 0 is up here at the top. Do you guys agree? Okay, it's greater than 0 from negative infinity to that point right there, which happens to be the what? X-intercept. So negative infinity to the x-intercept. Do that now. What's the x-intercept? Union. Then it picks back up, not at the x-intercept, but after the dotted line, which is what? At -2. So after -2, on to infinity. Oh, sorry. And then K is less than 0, and there's only one place here. That's from the x-intercept to the dotted line. It's a little piece. What's the x-intercept? -7/3 onto the dotted line. And that's it. Okay. You guys are finishing whatever I did not do with you is your assignment for today. Is this clear?